All right, good morning, boys. I hope you're all there. I'm having a little bit of a problem with the power going on and off, and thereby again connectivity with internet becomes an issue. So that is why this whole thing is becoming. Oh, somebody has come. Sorry. Let me first allow everybody to come in, and then we can have a better. You can see me. I hope you can. I hope you can hear me. Somebody tell me you can hear me.
Yes, sir.
Okay, that's good. Start our classes in about 5 minutes time. Let some more boys come in. Already we have 21 boys, so let them come in, and we'll start. There's Saurav Ranjan coming in, and this time I think last class I had gone and put in too much of information, and that information overload is probably going to make it difficult for you to actually absorb the subject matter. So today's class, we will go into the subject, but with the objective of you actually absorbing the subject matter. I shouldn't be simply pouring out the information to you and not figuring out how you're going to actually absorb the subject. It is very important that you absorb the subject while it is being told. It should not be while you're revising the subject. Absorb the subject while you're being told in class, and keep a piece of pencil and paper with you. There are some small bits or nuggets of information which I'll put across to you, which are not there in the power plant, in the PowerPoint. And have that those bits of information written down in a notebook or a pad or paper or diary, because not all the information you will have in the PowerPoint program. A lot of information that comes to my mind, I will share with you. So that will enhance your information, your knowledge also, and help you anytime you're asked oddball questions. All right, just Saurabh Gupta coming in. Actually, I was a little delayed because of this power outage, and then moment power goes off, the internet also takes a little time before it can come in. What they are doing is they are repairing some transformer, and for that there is a generator no doubt in our complex, but there's a time gap between the power load shedding or power outage and the generator coming on load. So that is why I was not able to come into time by 9:20. Mercifully, they have given us the power, and I hope it lasts. It may break off anytime. So I've given you a time of 9:45 for starting the program. And this class is 5E. So 5E has 38 candidates. All right. Shubhankar Singh is the class monitor. Any more? Today's 29. Another few boys are yet to come in. There they are coming. Sagar date. I know everybody has a little bit of problem with internet connectivity and connections. And whatever assignment I've given you, I hope you are attending to that. I am not going to correct it. I am not going to check it out. It is up to you. You want to do it. You want to learn. Okay, good enough. And on the 10th, that was on Thursday, I had been to office and I found quite empty, but the campus is very clean. But the hostel buildings look very, very deserted. They look like haunted houses, haunted buildings. And it's very sad to see an institution without its students. So actually, we are all missing you fellows in class, in hostels, in the campus to make it look a little lively. Otherwise, now it looks like a institution, sick institution because there are no students there, and it looks quite pathetic. So unless you boys come over and make it look a little lively, it is not going to look like an institution. So we hope by the end of this month there will be some indication that the colleges and hostels will open. we'll have to maintain some standard operating procedures. There now it's become a very common term, SOP. And on the basis of that, we'll have to open the hostels partially. I don't understand how. Possibly the senior years will get priority. That means seventh semester and fifth semester are probably going to be given priority over the third and first. First semester boys will also be joining. They have already been selected. They've had online tests. And when they will be joining, the exact date has not yet been finalized. So we expect your batch and your 1 year senior, the 2017 entry batch, to come first and be gradually absorbed in the college, maintaining certain procedures. All right, it is 9:45. Let us start our class and we will try. I don't expect to complete this full PowerPoint program today itself because there's a lot of information involved and I don't want to simply dole out all the information or overburden you. Somebody's come. Come sing. What sing is he? Saurav Singh. Okay, Saurav. I'll keep it over here so you can see and I can see also. So we are recording, isn't it? Okay, recording is on, camera is on. Oops, sorry. I can't see the chat section if you have anything to say. Okay, there's the chat section. Now let's start. In the last class, what we had done, we'll take it up from there. We had described two-stroke and four-stroke engine timing and the pressure and volume diagrams. A little revision on the four-stroke and two-stroke engines. We are going to continue now in detail, describing all the parts. Now you see this first picture that you observe here. It is a picture of an engine and it is not a marine engine anyway, but it's a four-stroke engine. How do you decide it's a four-stroke engine from here? You see, in the four-stroke engine, there are four strokes, all right? And in the two-stroke, there are two strokes. In the two-stroke, two strokes make one complete revolution of the crank, right? Okay. In the four-stroke, you have the piston going up, down, all right? So that up, down stroke, this is the main problem. Every time I have to upset the screen. So in the four-stroke, it goes up, down, up, down. So each time it goes up and down, one revolution of the crankshaft has to take place. All right. So this is the crankshaft, what you see here at the bottom of the diagram. And it makes one revolution, then two strokes are completely. But in the four-stroke engine, you need four strokes to complete the cycle. So this crankshaft has to revolve 2 times. So every 2 times it revolves, the camshaft, this is called the camshaft, this has to revolve once. Why? Because the suction valve has to open only once in the cycle. Likewise, the discharge valve or the exhaust valve has to also open once during the entire cycle. So during the entire cycle, the crankshaft rotates once and the camshaft has to rotate the crankshaft has to rotate twice and the camshaft has to rotate once. One revolution of this camshaft means 2 revolutions of the crankshaft because the piston has to go up and down 4 times, whereas the valve has to open only once during the whole cycle. Okay, so that is why the camshaft speed is half the crankshaft speed in four-stroke engines. All right, that's very clear. If you have any questions, do not hesitate to type out on the chat. Now who's come? Sarsaki Bhadra. Sarsaki, you've come pretty late. Anyway, that's there. So remember, the crankshaft speed is twice the speed of the camshaft. And over here we have a camshaft which is driven by the belt. This belt is not a metal belt. It is something of a V-belt medium. It's a rubber and reinforcement, fiberglass reinforcement within the strips over here. And it has got teeth. These are automobile belts which are used for automobile engines. But all right. So you see, normally the camshaft in an ordinary engine is driven by gears. There will be idle gears here, and then it'll have a camshaft. Over here we have a camshaft, which is overhead camshaft, OHV. Overhead valves are operated. These are the two valves. One is the inlet valve, one is the outlet or exhaust valve. You see the cam over here. The cam peak is over here, and in this case, the cam peak is down below. When the cam peak is down below, it means the valve is being pressed down to open. You can see the spring over here that has been compressed, whereas over here the spring has expanded because the cam peak is on top. Right now, the cam is resting on the valve cap on the base circle. The lower diameter, smaller diameter circle is called the base circle of the cam, and the peak of the cam is the peak circle, and that is presently active in this valve, in the one possibly the exhaust valve. So this exhaust valve is open, and this piston is on its way upwards. That is why the valve is open and the exhaust valve is open, so it is driving out the exhaust gases at the moment. All right. I should have put this as a question to you. From the diagram, tell me what is the direction of movement of the camshaft? Is it clockwise or anti-clockwise? This is anti-clockwise and this is clockwise. So from the diagram, can you tell me whether the rotation of the crankshaft is clockwise or anti-clockwise, assuming that this is the exhaust valve? It is obviously anti-clockwise. Why? Because the exhaust valve is open and this is now pushing the gas out. So these are little observations that you need to make, and you will notice that the camshaft diameter gear wheel is much larger than the crankshaft, which is also indicative the speed of the camshaft is much slower than the speed of the camshaft. All right. And this wheel over here is called the tension wheel. It's called the tension wheel or sometimes called the idler wheel. The purpose of this wheel is to keep the belt tight by pushing it and reducing the slack, the slackness of this belt. So this keeps it in a tight position, and the relative position of the camshaft and crankshaft are fixed. Decrease the length of the belt. Why will you decrease the length of the belt? It will not decrease the length of the belt, Saurav Gupta. It will make the belt under tension. That's all. It will not. Yes, right. In order to keep the tension. That's true. So, how is it that the timing of the camshaft is fixed with the timing of the crankshaft? It is fixed because it's got gear teeth, and these gear teeth on the belt fix the position of the camshaft relative to the crankshaft. There can be no slippage of the belt in this case. It is not like an ordinary V belt which will cause it to slip. All right.
Sir, excuse me, sir.
Go ahead.
Sir, I think what Saurabh Gupta tried to ask is that what is the exact purpose of the tension wheel if we can just produce that amount of tension but decreasing the length of the belt? This
You
is what he
can't
meant by asking that question.
you can't decrease the length of the belt. The length of the belt is fixed. It can be more than
No, sir.
it can be
From its construction, we can uh, calculate that what would be the minimum length of the belt which is required to keep the belt taut. I'm not saying to variably increase or decrease the belt, sir. From the
okay.
initial stage,
I get your point. I get your point. The idea is
yes,
to
sir.
keep the position of the belt fixed. You cannot decrease or increase the length of the belt, but to keep the pressure on the belt so that there is no loose motion or there is no coming off of the belt. And this wheel, it is kept under pressure by means of a spring. That spring tension will help to maintain certain pressure or spring compression. More than tension, it will be spring compression on this wheel will keep the belt tight so that there is no slippage, there is no looseness of the belt. That's all. In marine engines, you will have a chain driven belt, and that chain driven belt will be identical to this. The chain driven belt by itself will be a loose belt, and that belt is loose so that it is easily slipped onto the sprocket wheels. And after it is fitted on, there has to be some tension on the belt. So that tension is also maintained by a similar wheel that you see here, and it will have a spring compressioning on this idler wheel to keep that chain under a certain level of tightness. That tightness cannot be too much, it cannot be too little. And that chain, instead of driving gears like this, it is driving sprocket wheels. I hope you understand what is sprocket wheel. It is similar to what you see on bicycles. Those wheels which have got teeth on them, they are called sprocket wheels, and the chain slips over them, so there is no slippage. So that is what our engines for marine purpose use. Either it uses chain drive or it uses gear wheels. There will be a number of gear. Actually, this particular camshaft is above the engine. Normally, it is beside the engine, and there is one gear idler wheel which makes the camshaft run on the basis of the flywheel. Anyway, that is enough for this particular unit. Let's move on. Let us study two-stroke engines in detail. Oops, too big. Okay. I hope everybody has come. 36. And how many students are there in the class section here? 38. That means two boys are not present.
Sir, they
Anyway,
have their arrear paper today, sir.
oh, okay, okay. So there will be no more disturbance. Let's make this the biggest screen I can make. Ooh. Okay. Now, if you have any questions, a minute. Somebody has asked, Bhardwaj has asked a question. Sir, in case of two-stroke, will the crankshaft and cam wheel be absolutely right? Good thinking, Bhardwaj. The camshaft and the crankshaft in the two-stroke engine will have the same speed because the piston moves one revolution for both the strokes. That means the upstroke and downstroke. It moves one revolution. And the camshaft will also operate only one time because it needs to operate the fuel pump only once during that one revolution. Correct? Good thinking, Bhardwaj. Two-stroke engines, camshaft speed and crankshaft speed is the same. Four-stroke engine, crankshaft speed is twice the camshaft speed. Do not forget, especially at your basics, these are the questions you will ask. What is the relative speed of the crankshaft to the camshaft in the two-stroke engine? Is it the same in the four-stroke engine? If not, why? So be careful. Don't simply learn that it is twice the speed or same as the speed. You must be able to tell why it is the same speed and why in the four-stroke it is twice the speed of the camshaft. The question why has also to be answered, not just giving, yes, sir, it is twice and this is same. That should not be enough. All right. So let's go into comparative study of marine IC engines. Good, Bhardwaj, that you asked and got your concept cleared. Any other questions? Do not hesitate to write down. Don't go away by keeping quiet. Okay. Comparative study. These can be grouped under low speed engines, medium speed engines, and high speed engines. The low speed engines are generally between 55 and 150 RPM. The medium speed engine is somewhere 150 to 600, and high speed is 400 to 1000. Sorry, but last two classes I've been talking my head off, so it's given me a bit of a sore throat. So high speed, you notice something that there's a little overlap between medium speed and high speed engines. See, now manufacturers will tell you that their 500 RPM engine is a medium speed engine. In some case, another manufacturer will say my 500 RPM engine is a high speed engine. So there is always an overlap, and there is no hard and fast rule that it has to be at 150 RPM. If 150 RPM makes it a medium speed engine, does 149 RPM make it a low speed engine? So it's very difficult to actually categorize by digital differences. So there will be a little overlap in the speeds, but these are the general figures that are accepted in categorizing low speed, medium speed, and high speed engines. All right. Next, note very, very importantly and carefully because there have been mistakes made by some of our students at a later stage. All marine all marine engines are diesel engines. Petrol or gasoline engines are not permitted on board. Petrol by itself as a fuel is not permitted on board. You will be in deep trouble if you happen to store petrol on board the ship, because petrol is a major fire hazard, and the flash point of petrol is minus 20 degrees centigrade. And one more point I want to put down to you, very, very important. If you have a paper and pencil with you, just write down these 5 points, small points, and I will give you this as an assignment to find the answers. So write down on a piece of paper. First one, flash point. Just now I told you flash point of petrol is minus 20 degrees centigrade. You need to know what is flash point. So write down flash point. I will not tell you what it is. You have to find out. First one is flash point. Second one you write down fire point. FIRE POINT. Fire point. All right. Third one is ignition point. Flash point, fire point, ignition point. There are three different temperatures. There are three different temperatures. Now, we as marine engineers, our information on temperatures has to be a little more specific. So that is why flash point has a different meaning from fire point, and fire point also has a different meaning from ignition point. So flash point, fire point, ignition point. These are the 3 points related to engines and the fuel used for these engines. All right. Those are three. Number 4, you have pour point. Pour point spells P-O-U-R. P-O-U-R, pour point. It is the temperature at which pours, but you find out the exact definition. All right. And the last one, write down cloud point. C-L-O-U-D, cloud point. Clouds that you see in the clouds, that's cloud point. These 5 temperatures and their definitions should be at your fingertips. Very, very important. Okay, let's move on. So remember, do not make a mistake by ever saying that the engine, the lifeboat engine is a petrol engine, or the emergency generator is a petrol or a gasoline engine. You will fail in whatever exam you're appearing for. So do not make that mistake. Petrol is not permitted on board because it is a huge fire hazard. Next, let's go on to low speed engines. Low speed engines, these are usually large bore. That means the diameter of the cylinder is large. They are anything above 80 centimeters. Yeah, that's 800 millimeters. And the piston also will be proportionally large. These low-speed engines are generally of the two-stroke cycle. I have not known any four-stroke engine being a slow-speed engine. There are no slow-speed engines amongst the medium-speed engines. So low-speed engines are of the two-stroke cycle. Next one is the crosshead construction. Now this needs a little bit of clarification. This needs a little bit of a clarification. What is a crosshead? It will take some time to explain to you, so pay full attention to what I say. I will show you some diagrams also which will help in the understanding of a crosshead construction of a diesel engine. Now we have seen that the piston is attached to the connecting rod by means of a gudgeon pin or a wrist pin. So it moves angularly as the piston moves up and down. All right. Okay. Now suppose you have a long stroke engine. A stroke of the engine is very long. All right. It means the diameter of the crank will also become large, because the bottom of that circle to the top of the circle would mean the stroke of the engine. That means that is the distance the piston is moving in the cylinder liner. So this large diameter crank would also mean a wider engine, because the crank has to rotate on a larger circle. So you have a very wide engine. Now to reduce the height of the engine, what the manufacturer do, they reduce the length of the connecting rod. Now, if you reduce the length of the connecting rod, then the angularity of the connecting rod becomes very large. That means from the vertical, when the piston comes down, the angularity of the connecting rod is going to be quite large. All right. Now, this angularity of the connecting rod, if it is large and the cylinder liner is very long, then the edge of the connecting rod is going to contact or hit the cylinder liner when it is coming down near the midway between the TDC and BDC. All right. Now, if it hits that connecting rod, the connecting rod or the cylinder liner is going to break. So, how do you accommodate this angularity without the connecting rod touching the bottom of the cylinder liner? Okay. Now, what will you do? So, what we do is to extend the piston. You cannot really extend the piston. So, you have a piston and a rod fitted under the piston. So, that rod extends below the piston to such a length. After that, you fix the connecting rod onto the end of the piston rod. So, the piston rod is separate, the connecting rod is separate. So, the piston rod, which will help in moving the piston up and down, and the connecting rod can move to the required angle as it wishes, and it will not touch the cylinder liner. So, to have a place where the piston rod and the connecting rod can be connected is the position of what is called the crosshead. This crosshead has to be guided so that the piston moves in perfect vertical position so that the whole piston doesn't start shifting. So the crosshead has to be given two guides in which the crosshead will slide up and down. And on that crosshead, you will attach the top end of the connecting rod to allow the connecting rod to swivel. So the top end of the connecting rod will move up and down at the same time be able to swivel. All right. Now, because there is a piston rod, it is coming down much lower than the end of the cylinder liner. So this angularity of the connecting rod will not interfere with the cylinder liner. Let's have a look at a diagram. Okay. Then it will become easy. Now, in this diagram, I've given you both the engines. Both can be two-stroke engines. Now, both can be two-stroke engines. One is with a crosshead and one is without a crosshead. You see, when the stroke is short, the angularity of the connecting rod can be accommodated. But if the stroke is long, then the angularity of the connecting rod will interfere with the liner. You see over here, it is almost touching the cylinder liner. This is the connecting rod and this is the liner. What you see here, what you see here is the liner. So if the stroke is very large, then this diameter of the crank will also become very large, isn't it? Because the diameter of the crank is indicative of how much the stroke is. So if the height of the circle becomes large, obviously the horizontal diameter is also going to be large. If the horizontal diameter is going to be large, then the angularity of the connecting rod is also going to be large. So if it becomes large, it will hit the liner. The connecting rod will hit the liner. To avoid this problem, we have fitted one piston rod, and on the end of the piston rod, we have attached the connecting rod. And the means of attachment is called a crosshead. This is like a block with two pins sticking out from the sides. So the connecting rod bearings are fitted on those pins. The crosshead by itself cannot be hanging midair. It has to be given a guide. So what you see, these two plates over here, they are providing the guide rail for it, the crosshead to move absolutely in vertical alignment. And at the same time, it allows the connecting rod to swivel in either direction as it keeps rotating. Okay, so what is the crosshead? It is a means to connect the piston rod and the connecting rod, the crosshead. All right, and this is required in long stroke engines. Why it is required? Because the long stroke will create a large angularity of the connecting rod, and this angularity will interfere with the bottom portion of the cylinder liner and may cause it to break or make contact, which is not feasible or permissible. So to avoid this, we are required to have a Crosshead. Remember, a two-stroke engine need not necessarily have a Crosshead, but most students are brainwashed into believing Crosshead engine must be two-stroke engine. No, that is not the way it is. A Crosshead engine is an engine with a long stroke. A two-stroke engine may not have a crosshead. If the stroke is short, why have a crosshead? Doesn't make sense. It is additional equipment, additional attachment, additional maintenance, additional lubrication. All are additional work. But two-stroke engines are still preferred in spite of having this difficulty of a crosshead because they can burn very poor quality fuel. And fuel cost for a ship owner is 60% of the cost of running the ship. So it makes sense to burn poor quality fuel. And to burn poor quality fuel, you need more time for the fuel to burn. That is why slow speed engines with a long stroke allows for the fuel to burn continuously and completely by the end of the stroke. All right, let's get back. So that is what is crosshead construction. We will go in detail regarding the crosshead at a later date. I will go to all the parts and describe them in detail. Right now, we are describing low speed engines in general. Okay. So they have a large bore, they are run on two-stroke cycles, they have crosshead construction. Usually, because they are low speed engines, they will have crosshead. The higher speed engines of two-stroke will not have a crosshead. Higher speed two-stroke engine will not have a crosshead. There's another point you must remember. Because it's a two-stroke engine, a lot of boys or a lot of students assume that it has to be a slow-speed engine. No, that is also not true. A two-stroke engine can be a high-speed engine also. But one of the drawbacks of a two-stroke high-speed engine is causes a lot of pollution. The gas exchange process is not given enough time. So that is why a lot of polluting gas, which means unburned fuel, goes out as pollutants. Okay. Next is after, oh, 1 minute. I have not finished the last 2 points. These low speed engines, they have direct drive to the propeller. They don't need any gearboxes or reducing gears or anything like that. So the engine is directly coupled to the propeller. There is no clutch system at all. It is directly from the output of the shaft into the propeller. So it makes it so simple. No additional equipment on board, no further maintenance, no upkeep. So it's so clean cut. Okay. Next is the crank and cylinder spaces are separate. Very true. See, you have a long piston rod. Okay. At the section where the piston rod travels, you have a horizontal plate. This horizontal plate is called a diaphragm, and the hole through which it travels inside that plate, you have to have a sealing arrangement. You need to seal that space above the plate and below the plate. What is above the plate is called under piston spaces, and what is below the plate is called crankcase spaces. Let's have a look at the diagram once again. Here is your two-stroke engine, all right? The plate is here. You see, this is the piston rod. Let's make it a little bigger. Oh, sorry. Okay, I think now the diagram is a little bigger. And, oh, because if you have a chat question, then I won't be able to see. I want to see if there's any question. Okay, now let's have a look at the diagram. I hope the diagram is quite clear. Yeah. Okay. Now, this is the plate, horizontal plate, which I was talking about. And on this plate, you have a hole. And through this hole, the piston rod is passing. But you need to provide a sealing arrangement on that piston rod, because this under piston space that you see is the space that is used as a pump, air pump. It is called under piston scavenge spaces. All right. Now, air which is coming to the engine, it comes in stages. First stage is it comes to the turbocharger. Turbocharger is the device which draws air from the atmosphere, compresses it, and sends it into the air pipe. From the air pipe, the air is fed to individual units of the engine. Okay. So actually, in some engines, there are two stages over here. Air comes into that air manifold, and that air manifold has air at a temperature of 130 degrees centigrade, because when you compress air, the temperature rises. So this air has to be cooled. So after it is cooled, it is passed on to a certain section of the air manifold. From here, there are non-return valves. These non-return valves allow the air to come only in one direction, and it comes in the under piston spaces. This is the under piston spaces. All right. Now, once it comes into that space, when the piston comes down, it is like a pump. It pumps that air under the piston and compresses that air. So that air now under pressure goes through another set of non-return valves and goes into another chamber of the air manifold. From that air manifold, it goes directly to the inlet ports. So there are two stages of compression. One is first the turbocharger compresses the air. After the compression by the turbocharger, it is cooled. After cooling, it passes through non-return valves. It comes into the under piston spaces of what you see over there. From the under piston spaces through another set of non-return valves, it goes to the air manifold, from where it goes directly into the inlet ports of the engine. So the air pressure is much higher than what the turbocharger can deliver. And because the density has increased, the mass will have increased, and thereby it has got better supercharging characteristics. So right now, let us focus on the parts of this engine, what we have here. So this piston rod is sealed by means of a sealing arrangement. This sealing arrangement is called a stuffing box. It is also called a piston rod gland. All right. This piston rod gland provides to separate the crankcase spaces and the under piston spaces. These are under piston spaces, and the spaces below this gland is all called crankcase spaces. All right. This crankcase space has got oil which is lubricating all the components, and that oil is called system oil or crankcase oil. And this oil is different completely from the oil which is used for lubricating the piston and liner. So that is why it is very necessary to have this sealing arrangement, so that the oil from the piston does not enter the crankcase and contaminate the oil in the crankcase. So the two oils are separate in the case of the two-stroke engine. The oil which is used for cylinder lubrication and the oil which is used for crankcase lubrication. That means the bearing of the crosshead, the bearing of the main bearing, the crosshead, the bottom end bearing, and the main bearing. So there are three bearings over here, and these three bearings are lubricated by system oil or crankcase oil, and this oil is separate from the oil that is used for lubrication. All right. In the trunk type of engine, or rather four-stroke engine, now let's assume this is a four-stroke engine. In the four-stroke engine, no separate oil is given for piston lubrication. You see, the piston is open to the crankcase. So when it is running, it will lubricate by splashing the oil inside the lubrication oil onto the cylinder liner. All right. And this piston will draw that oil along the cylinder liner to lubricate that piston. If you see on the piston rings, I showed you in my earlier class that the piston has got two compression rings and one is a oil control ring. This oil control ring is actually a ring which scrapes off excess oil and pulls it back into the crankcase. So the oil that is splashing here splashes onto the insides of the liner, and excess oil which might go up into the combustion chamber is scraped off by means of a oil scraper ring. All right. So this oil scraper ring helps to reduce oil loss. You must be wondering, if it scrapes off the oil, then what lubrication is there? Now look at it. If I have a steel plate, ordinary steel plate, and I pour water on it, and I take a cloth and I wipe it off, so all the water is gone, isn't it? Now the same steel plate, I pour some oil on it, and then I take a cloth and I wipe off. Has all the oil gone? No, some oil is still there sticking to the surface. Unless you use sodium hydroxide, you use soap, then only that oil can be washed out. Otherwise, simply putting oil on a steel plate and wiping off, the oil does not go, it sticks. So this is one huge advantage for all machines. Any machine which is having rubbing action, if you drop oil on it, even if the oil falls off, there is still oil on it to provide the minimal lubrication between rubbing surfaces. Get it? So that is why you just need very little oil between the cylinder liner and piston. So what oil splashes on the insides of the liner is too much. So you have an oil scraper ring which will scrape off the excess oil and let some trace of oil remain on the piston ring and the liner to provide for the necessary lubrication. Okay. What I needed you to understand is this concept here, where the crankcase space and the under piston spaces are separated by means of a diaphragm. I have a better diagram and I'm going to show that to you. You keep your cell phones ready and take a snapshot immediately. And then from that snapshot, hand draw and practice that diagram. That is the diagram you will be required to draw in an exam. This is not the diagram, nor are those fancy pictures that I've shown you that will be required of you to draw in the diagram. But I will give you a diagram which you can actually draw easily. And that diagram has the names of all the parts, which will help you to also improve on your naming parts of the engine. Okay, so let's get back to our subject. Yeah, sorry, we were on this one. We were on this one. Have direct drive to propeller. There's one more, I think. Yeah. Crankcase and cylinder spaces are separate. I hope now you understand that crankcase and cylinder under piston or cylinder spaces are same. This is the cylinder. So these spaces are separate from the crankcase spaces by means of a diaphragm, and within the diaphragm you have a sealing arrangement which is called a stuffing box. It is also called piston rod gland. All right. So don't forget, you can write these small notes. Stuffing box is not the only name for it. It can be called piston rod gland, and it consists of several rings. It's quite a complicated setup, and it helps in sealing the under piston spaces and the crankcase spaces, and any oil that is scraped on the piston rod is drained out. All right. There's a drain for the oil which will allow the under piston spaces oil to be drained out of the engine, because cylinder oil, once it is used, it cannot be reused. But crankcase oil, it is continuously being reused. You have a separate arrangement to continuously clean this oil. It is called centrifugal purifier, but that will come to later. Remember, this system oil in the engine is similar to your blood system. Absolutely similar to your blood system. Any problem with the engine, you can identify by taking a sample of the lube oil, sending it to the laboratory, and understanding. Oh, there's another question by Shubh Bhardwaj. Sir, why don't we use 4-stroke cycle engine on board? Bhardwaj, of course, we use 4-stroke cycle engine on board. Not all engines on board are 2-stroke cycles. They're auxiliary engines. where the fuel cost is the biggest problem. They are all four-stroke engines. The emergency generator, that is also a four-stroke engine. The lifeboat engine is also a four-stroke engine. And in some cases, you have an emergency compressor, which is also run by an engine. That engine is also a four-stroke cycle. We use, don't believe, because I am describing two-stroke is the main propulsion engine only for running the propeller. Two-stroke engine is not used for any other purpose. So the main engine, which is very common for most ship owners, is a two-stroke engine because it can burn very low quality fuel. Four-stroke engines generally could not earlier. Now they have been modified and they can burn, but they have certain restrictions. Because of those restrictions, they are put aside. And owners are still preferring two-stroke engines. Not that four-stroke engines are not used for propulsion. They are also used for propulsion, but you will need possibly two engines or a V engine to give that additional power. All right. So where was I? So you now understand crank and cylinder spaces are separate. Okay. This is where your crank and cylinder spaces are separate, but in the non-crosshead type, these are called trunk type of engine. Why is it called trunk type of engine? So where is the excess oil scraped off the cylinder used? I told you just now, any oil that is scraped off from the cylinder liner and falls on the diaphragm has to be rejected. There are drain pipes from there leading out of the engine and they go into a sludge tank. That oil is gummy, sticky, full of carbon, and okay, it has been neutralized, no doubt. But that oil cannot be used again. It is a one-time use. Cylinder oil is a very costly oil and it is a one-time use oil. You cannot reuse that oil. But the crankcase oil, what is inside here, that is used continuously and almost never changed. It is never changed. Even if it gets dirty, it is passed through a purifier for continuous cleaning and put back in the crankcase oil. It is similar to your kidneys. This is your blood system, what you see inside the engine, the oil that is used. And it has kidneys, and those kidneys are called centrifugal purifiers. They purify the oil and put it back in the engine, much like your kidneys. But that we'll go to later. We are going off the topic at the moment, and Chatterjee, you're leading me off the topic. But anyway, do ask questions. The excess oil scraped off the cylinder is not used again, ever. It has to be rejected. It is like sludge. Okay? Okay. Next point is, now I will show you, all this time I've been talking about a two-stroke engine with a crosshead. Now here is the diagram of showing you two different engines. Both are without crosshead. IC engine two-stroke, no crosshead. This engine is also two-stroke. This is also two-stroke. There is no crosshead over here. And this air which is coming in through the port. Once it comes in through the ports, it comes into the cylinder. And after combustion, you see this particular engine, I think it is a shore-based engine. It has got two exhaust valves. Both the exhaust valves open and allow for better removal of the burnt gases. It is as essential to have removal of the burnt gases to ensure that the new charge of air is got maximum oxygen supply for better combustion in the next cycle. So here you have an engine with two exhaust valves and one injector. Over here, this is more appropriate to marine engines, and you will see the scavenge manifold or scavenge air trunking or air manifold. It has got various names, but it means the same. It has got ports over here, which allows the air to come in when the piston is at BDC or near BDC and fills up the charge. And then it has got one single exhaust valve on top, which opens at the exhaust when the exhaust is required to be opened. That is just before the piston reaches BDC or before it opens the scavenge manifold, the scavenge ports, the exhaust valve is opened. So whatever little pressure is built up is allowed to go in, And when the piston goes down further and air pressure comes in, it pushes out the remaining gases. So that is your scavenging arrangement. Okay, so these two diagrams are indicative of two-stroke engines without the crosshead. Okay, the main parts of a two-stroke engine. You can read this. I think the diagram is quite clear. Okay, I hope you can see me. I'm also, yeah, you can see me. So that is your diagram. So where is the, okay, any more question? Good, you asked this question because a lot of boys, they don't know about this cylinder oil being thrown out once it is used. They think it can be used again, purified and put back. No, it cannot be used. It is rejected. Okay, now main parts of a two-stroke engine. Main parts of a two-stroke engine. The combustion space and scavenge space are separated from the crankcase by the diaphragm plate. This is the diaphragm plate, and that is the same diagram I showed you earlier where the stuffing box is. That stuffing box is a sealing arrangement on the piston rod. Remember, the piston rod surface is mirror finish. It's very smooth and it is shining like chromium. It is polished and polished and polished. Where is it scraped? It is scraped into the sludge tank. There is a separate tank where the sludge oil goes. From where cylinder oil is sprayed inside the cylinder. Okay, you're going into depth. Okay, let's go back. From where it is delivered into the cylinder liner. Okay. Okay, let's make it a little interesting. Of course, now two-stroke motorbikes are no longer in fashion. All the motorcycle bikes are all four-stroke. But I remember when the two-stroke, and I don't think you boys will remember because you have not ridden two-stroke motorcycles. The principle of lubrication is the same. Okay. Now these motorcycles, two-stroke motorcycles, they had a fuel tank. All right. And in this fuel tank, we used to add a little mobile, that is the lube oil, and then fill the petrol. So ultimately, the petrol and that mobile oil, they used to call it, actually it is lubricating oil, is to mix. So that petrol in the two-stroke motorbike was a mixture of lubricating oil and petrol. In the four-stroke bike, you only fit petrol. You don't fill lube oil in the petrol tank. You have lube oil in the crankcase of the four-stroke engine. And in this two-stroke engine, you do have crankcase oil, but you also have the fuel tank filled with lube oil. Okay. Now, this is a major issue, and Shekhar, pay 100% attention. Now, when you're riding the two-stroke motorcycle, the piston needs lubrication. And that lubrication comes from within the petrol because mobile or lube oil was mixed with it. All right. And since this piston is working inside, it is getting its lubricating oil because the petrol burns out, but the lube oil does not burn out. The lube oil partially burns out and partially remains on the surface walls. This provides for the lubrication of the piston and the ring for the two-stroke motorcycle engine. Part of the lube oil burns out and comes out as vapor, lube oil vapor. Petrol, of course, burns out completely. This lube oil vapor, which comes out from the exhaust, comes out through the exhaust pipe and out into the atmosphere. And that is what causes pollution. So in a two-stroke motorbike, if you see the exhaust pipe at the end and put your finger there, you will find it is wet. It is wet with oil. So that is what distinguishes a two-stroke motorcycle. In a four-stroke motorcycle like the Bullet, you can go, when you go to college, you check out KD sir's motorcycle. He's got a Bullet, and you check out the exhaust pipe and you'll find it is dry powder, dry black powder. In the four-stroke, the exhaust pipe is dry. In the two-stroke, it is wet. Why? Because the lubricating system for the pistons for either are different, completely different. In the four-stroke engine, the lubrication of the cylinder liner is from the crankcase lubrication. In the two-stroke engine, you are putting in lube oil with the petrol, which is being fed directly into the combustion spaces. So that is why the oil has direct access to the piston, ring, and liner. Part of it burns, part of it does not burn. What does not burn comes out as vapor and it goes and deposits along the exhaust pipe. And that is why the pipe is wet. Now, in the case of our marine diesel engines, in the two-stroke engine, Shubham Sarkar, how is the oil delivered between the liner and piston? You have a separate lubricator pump. They are small little pumps and they have crankshaft within, and you have a separate lube oil tank which fills up this lubricator. This lubricator has small pipes which lead to the cylinder liner at the top one-third of the height of the liner. The pipes are not right up, they are not right down, they are not in the middle. They are in the upper third height of the liner. Now, this lubricator is run by a mechanical linkage, and the central crankshaft of that lubricator is about how much? 10 inches by 4 inches by 6 inches. Small lubricators. There may be 2 or 3 of them. Each lubricator will deliver oil to maybe 1 unit or 2 units. And multiple pipes coming out from there, the diameter of a pencil. The pipes are a diameter of a pencil. And these pipes go on the cylinder liner at, say, there are 6 pipes. So 60 degrees from each other, the pipe will be having entry into the combustion chamber. All right. And when the engine runs through the mechanical linkages, it runs the lubricator. This lubricator is filled with oil. And this lubricator is actually a miniature pump, multiple miniature pumps. So there'll be 6 pumps in each, and each of these will deliver oil to the cylinder liner. So each time the piston goes up and down, oil is delivered directly into the cylinder liner for lubrication. Usually a little excess is given because nobody wants under lubrication, preferably slight over lubrication for safety. But remember, over lubrication is as bad as under lubrication. Too much oil is as bad as too little oil. So chief engineers, to stay safe, they make marginally more. So that oil ultimately finds its way onto this. It is falling along the cylinder liner walls and onto this diaphragm over here. And as it comes on this diaphragm, it starts filling up this place. That is also bad. So a pipe is led from underside of that diaphragm and out of the engine and leads the oil to drain out. So this drain passage has a cock, a right-angled lever operating a cock. You as a junior engineer on board will be required to operate that cock every few, say 20 minutes or half an hour or 1 hour, depending on what is the general practice on the ship. If you do not drain and this thick, sticky lubricating oil settles on the top, it will solidify or semi-solidify. Once it semi-solidifies, it will not pass through that pipe. Even if you keep that valve open, it will not come out. It is sealed. And then accumulation of that oil will increase, increase, increase. If for some reason there is blow past means the combustion gases with flame passing the piston rings will ignite that oil mass and you will have what is called a scavenge fire. All right. Up to that, we will say enough for now. From where is the oil sprayed inside the cylinder? So you have separate oil pipes which are fed into the liner for delivery of cylinder oil. All right, Shubham Sarkar, that is our question addressed. Any more questions? Put it up on the chat. So combustion space and scavenge space. Scavenge space is what you see in blue and combustion space is up over here. They are not separated. What he has said here is not right. Combustion space is not separated. It should have been crankcase spaces. He has made a mistake. I've copied this full thing. Now I don't know how to change this. He should have said scavenge space and scavenge space. It should have been under piston space and scavenge space are separated from the crankcase by the diaphragm plate. It doesn't make sense. What he has said here, just remember under piston space and scavenge space are separated by a diaphragm. The combustion space is the combustion space. It is integral. It does not have anything separate from. It is integral and there is no separation from anywhere. It is integral and by itself. What is separated is the scavenge space and the crankcase space. The combustion space is inside the cylinder liner. It cannot be separated by anything. It is enclosed space by the cylinder liner and the piston and the cylinder head on top. So that cannot be separated. This statement over here needs a little correction. This has been copied from the internet. So I should try. I don't know how to remove it. Review, view, design. Let's see, you need design, background, hide background, colors, no, no graphics, no, background spaces, no. There should be some eraser. Review. No, anyway, we are wasting time. So remember, this sentence here is not correct. Only the under piston spaces and scavenge spaces are separate from crankcase spaces. Combustion spaces inside the cylinder and not separated by any diaphragm or anything. All right. Now get your cell phone ready and take a snapshot of the next picture that I'm going to show you. Yeah. This is the diagram I wanted to show you, and you need to take a snapshot with your mobile. Okay. Now this is a line diagram which you can actually draw. This is not a diagram which is difficult to draw, but you need to practice and you need to know the names of the parts. All the names of the parts are given over here, and it's quite simple to understand. Now let me try and explain this to you. The air is coming in from here. All right. It comes into what is called a turbo blower, which is part of a turbocharger. The turbocharger, what it consists of is actually a shaft and two fans. Consider them as fans. One fan this side, another fan this side. Now, when you blow air on one fan, obviously it is going to rotate. Exhaust gases are led onto one fan and it rotates that fan. Because the fan rotates, the shaft will also rotate. The entire assembly of the two fans and one shaft is called a rotor, R-O-T-O-R. This rotor will rotate if exhaust gases are forced onto the fan blades. And since the fan rotates, the whole rotor will rotate. On the other side, the other fan is made in such a way, the casing is made in such a way, the blade angles are made in such a way that it will draw air from the atmosphere and pump that air into the air manifold. All right. So the exhaust gases which are coming out from this exhaust trunking will rotate the rotor, and the turbo blower side will blow air and then pump in that air into the air manifold or scavenge manifold. This air is at a temperature of 90 to 130 degrees centigrade, which is very, very hot. You cannot afford to put such hot air into the engine. Then the temperatures will go super high. So you need to cool it. So then you have what is called a air cooler. This air cooler works with seawater. That is why seawater is used, because you have the coldest water that is available to you is seawater. That water is circulated through the cooler and the air passes through that cooler and it provides for cooling. This temperature from 130 or 90 degrees centigrade is brought down to 40 degrees centigrade. All right. Once it is brought down to 40 degrees centigrade, What is not shown over here is a set of non-return valves. These non-return valves allow for the air to come in under the piston piston. Okay. Now, once it comes under the piston, when the piston comes down, it goes out through another set of valves and then it goes into the ports. So once it goes into the port, the piston is at BDC or near BDC. And then air, this is the cylinder where it is charged with air. And then combustion takes place with the fuel injection, etc. And then this is the exhaust valve. This exhaust valve will open to allow the exhaust gas to go out. Okay. Now this exhaust valve is operated by means of what is called a rocker arm. This rocker arm is in turn operated by means of a push rod. The push rod above a rocker arm or above a camshaft. On the camshaft, you saw that there is a cam with a base circle and a peak circle. The peak circle, when it comes to the top, will push the one end of the rocker arm and the other end of the rocker arm will go down to open the valve. So this rocker arm is actually operated by the engine itself through a drive mechanism, which may be a chain, which may be a gear drive. And then once it operates the cam, it operates the valve. The timing of the cam has to match the timing of the requirement of opening and closing of the valve. This jacket where the cylinder is water cooled. So there is a jacket and there is a cylinder liner inside. Between the liner and the jacket, there are void spaces. This space is filled with water. So this water provides for cooling of the liner because the liner becomes very hot after some time of operation. Okay. Now, this is the piston, and below the piston, you have what is called the piston rod. This piston rod is a rigid rod, and that rigid rod passes through what is the diaphragm and the stuffing box, where the sealing is arrived. So this seal restricts any air from here coming into the crankcase, and it also restricts any oil from the crankcase going into the under piston spaces. This space, what is below this level, is called the crankcase spaces. You have the crosshead. The crosshead is allowed to move up and down by means of guides. These are guides which keeps the crosshead in position and maintains the alignment of the piston, liner, crosshead, crank pin. All are in alignment. This alignment is very necessary whenever there are gas forces coming into being. Okay. So this connecting rod is now connected to the crank. The crank is shown as a circle over here, and the entire space is enclosed by means of a crankcase door. This crankcase door is actually much bigger than what he has shown here. It can be opened for man entry. If you enter here, you can come and sit over here. You can sit here, you can get inside, you can walk about. It's a big room, so you can walk inside that room. Any questions in understanding this diagram or any part of the lesson that I have already explained to you? Do not hesitate to ask questions. Okay, let's move on.
Excuse me, sir.
What is it?
Sir, what happens to the air after it passes through the air cooler, sir? Please repeat it again, sir.
Oh, okay. Over here, he has shown a very simple diagram. He has shown after it passes through the lube oil cooler, it goes into this scavenging manifold over here. So when the piston comes down, it goes through the ports and charges the cylinder. All right. But in the more modern engines, the underside of the piston is used as a pump. So what air comes in here first actually goes under the piston, and it comes into the underside of the piston by means of some non-return valves. They are not shown over here. Those non-return valves allow the air to pass only to the underside of the piston. And then there is another set of valves above those set of non-return valves which allow the air to come on this side. And they are separate chambers over here. These separate chambers allow for differential pressure. So once the air is compressed by the piston when it's moving down, it compresses the air and sends it to another part of the manifold where it can go directly into the ports and fill up the cylinder. So there are actually two stages of compression over here, but right now, for the sake of simplicity, they have shown only one stage. In the more modern engines, there are two stages. But for your fifth semester, keep it to a single stage. But be aware that there is the second stage, and the under piston spaces is used as a pump. So you get better efficiency of the engine. So you don't waste anything. So that is what the air is doing. It goes into the cylinder as fresh charge air. Is that clear? Have you understood?
Yes, sir. Yes, sir. Yes, sir.
Okay. Okay. If you have any more questions, I will explain more. But for your fifth semester, this single stage charging is adequate. In your sixth semester, you will go into a little more complicated areas of engine function. For right now, I hope you have taken a snapshot of this. You can practice this diagram at leisure. Next, we are going into medium speed engines. Okay, so medium speed engines most operate on the four-stroke cycle. All right, let me put down this as a note. On the four-stroke cycle, and they are of the trunk piston construction. What is trunk piston construction? Now we come to a position where you will have to think a little more, and this is because we are going to consider all the forces that are acting on that piston. Okay, most operate on the four-stroke cycle, that everybody understands. They are of the trunk piston construction. Now this is a trunk piston construction. What does this trunk piston construction? The word trunk means, you know, sometimes it is used for your own body. Trunk of the body. That's the mid position of your body. Your waist, your stomach, and lower chest part is called the trunk of your body. Similarly, for the piston, the portion below the piston ring, sometimes it is called the skirt, sometimes it is called the trunk. And in this case, why it is called trunk? Let's have a look at it. When combustion takes place, there is a gas force acting on top of the piston. All right. This gas force on the piston pushes on the connecting rod. All right. If the connecting rod is straight along with the piston, then the force on the connecting rod is also straight, right along the piston rod. Okay. But after TDC, when the connecting rod makes an angle to the center line, then the force is transmitted at an angle. All right. It passes through a particular angle depending on what position the connecting rod is. Now, because of this angularity, there will be a transverse force. How to show you the transverse? Actually, I made one diagram. This vertical force is translated to an angular force. And because of its translated force, there will be a resultant horizontal force. This horizontal force is called a lateral force. And this lateral force is acting through the trunk of the piston onto the liner. Are you able to understand? You have to imagine these forces. I cannot show a force because it's an imaginary quantity. So the force arising out of the gas pressure on top of the piston pushes the piston down. That is vertically down. But the piston is pushing the connecting rod, and the connecting rod makes an angle to the vertical. So the force is also coming down at an angle. And because the vertical force is translated to an angular force, there will be a resultant, or what is in mechanics, it is called the resultant force. No, not resultant force. Uh, it is the offshoot force. So there is another force which is horizontal. This force is called a lateral force, and this force is acting through the trunk of the piston. So whenever there is a gas force, the piston is pushed down. One side of the liner is being pressed much more, than the other. All right. Similarly, when the compression takes place, again, the angular force is being translated to a vertical force. So there will be a resultant lateral force. So because of this lateral force, the wear down of the cylinder liner is oval. It is never absolutely even wear all around. It is oval. That means one side of the liner is worn down much more than the other. In the case of the two-stroke engine, when there is a vertical force down and it is translated into an angular force through the connecting rod, there will be a lateral force through the guide and guide shoe. So this guide and guide shoe ultimately transmits the force onto the A-frames. This is what is the A-frame. These are A-frames, and these A-frames on the side of the thrust is made very, very rigid. So when you happen to get a chance to go to college, do visit that big engine we have in our workshop at the back. You will see the side on which the main thrust is. The engine is running mostly in the ahead direction. This is a propulsion engine. It is running in the ahead direction. So if, let us say it is running in the ahead direction with this rotating, if the piston is coming down and this is going up. So the force is in this direction. Okay. So now this is rotating in this direction. Let us say it is rotating in the clockwise direction. And the force on the piston is causing enormous lateral force. So this side of the A-frame will be much stronger than this side. In the direction where the lateral force is acting when the ship is moving in the ahead direction, the A-frames on that side has to take the lateral force. This lateral force has to make the A-frame much stronger to resist that force. Astern force will be in the opposite direction and the force will come onto the other A-frame. Once it comes to the other A-frame, the force is there. But remember, we do not run astern at full speed or full power. We run astern only for maneuvering the ship. So the astern force on the crosshead is much, much less than the force when it is on full power and running on the ahead direction. That is why the A-frame on the ahead direction force is made much stronger than the astern direction force. Okay, and this lateral force is arising out of the angularity transmission of the force from the piston rod to the connecting rod and then to the crank. So in the case of the trunk type of engine, it may be two-stroke, it may be four-stroke. That is not the point. This is a trunk type of engine. So when the gas force acts on it and transmits the force through the angular connecting rod, there will be a lateral force, and this force will be acting through the piston at the mid position. This or at the position where the gudgeon pin is acting. In that line, it will act on the side of the liner, and that is called the lateral force taken up by the trunk portion of the engine. Okay, okay. They are of trunk piston construction. Four-stroke engines are of the trunk piston construction. Also, two-stroke engines can be trunk piston engines where the stroke is small. And these medium speed engines are smaller and lighter than the slow speed engines. Obviously, the components are smaller, they are lighter. Okay. The bigger size medium speed engines are used for propulsion. See, when we were in your stage, we were told medium speed engines, four-stroke engines, they cannot run on heavy oil. They cannot run on residual fuel, which is also called heavy oil. They can only burn on the light distillate fuel. That means fuels which have been distilled. Very clean, very good quality. They don't dirty anything. But very soon in 1973, we had just joined ship and suddenly the oil prices went up. And that time all our medium speed engines were burning distillate fuels. The price of oil shot up and then it became very costly to run our generators, which are four-stroke engines, on light diesel oil, or on distillate fuel. So the quality of fuel the company started buying for those generators started getting lower and lower and lower. And we started having problems on the ship. Incomplete combustion, carbon deposits, smoke from the funnel, not much of power coming from the engine because the price of fuel went high. All right. So that is why research went into making four-stroke engines also to run on heavy oil. And today, there are four-stroke medium-speed engines which are running on heavy oil, but they need added gear to prepare that oil before it is injected. And after it is injected, that oil has to burn completely. And if the engine speed is too high, that oil cannot burn. So ultimately, you will be discharging black smoke. So to avoid this, they have made a restriction on medium speed engines for burning heavy oil. And what is that restriction? The restriction is the RPM, the revolutions per minute. That determines the piston speed and that determines the time available for the fuel to burn. So that speed is restricted to 750 RPM. All right. So 750 RPM is the maximum speed a medium speed four-stroke engine can burn heavy oil. Okay. The bigger size medium speed engine are used for propulsion. That's very true. The biggest size medium speed engines, they can be used for propulsion. If the ship is large, they will use two engines. Or they will use two V-type engines. That's as good as four engines. So they are coupled by means of reduction gear and the propeller. I want you to study one particular medium speed engine. And that speed engine is Wärtsilä. Wärtsilä's, we have not come to that. I think you have missed some plate. Oh, we have missed this plate. I'm sorry, I overshot. Actually, what happens when I start talking on a subject, I go deeper into this. We have not finished the low speed engines. That is why I was surprised. We have not come into this area. Okay, let's go a little bit. Slow speed engine, this we have done. Suited for ocean question. Stroke to bore ratio. The stroke to bore ratio determines the size of the engine and the implications involved. Now, when I say stroke to bore ratio, I say 1.2. It means the stroke is 1.2 meters and the bore is 1 meter. All right. If I say stroke to bore ratio is 3.2, so it means the stroke of the engine is 3.2 meters and the bore is 1 meter. If I say the stroke is 4.7, it means the stroke is 4.7 and the bore is still 1 meter. So 1.2, in fact, even 1 is also a stroke to bore ratio, and those engines are called square engines, where the stroke and the bore are the same. So 1:1. The long stroke engines are having a stroke to bore ratio of 3.2. Super long stroke engines are somewhere in the region of 4.7 meters. These are super long stroke and they are called green engines. All right. So these engines are given the poorest quality of fuel, and because the stroke is so long, they are enabled to burn the fuel completely by the time the piston reaches its bottom dead center. And they are very slow speed engines, and you saw it is coming up to 55 revolutions per minute. Almost one complete second it takes to make one revolution. Manufacturers. Now, this is also a very important point, and after this, we'll call it off because it's already 11:03. Manufacturers, there are three main manufacturers of two-stroke engines. All right, they are MAN and B&W. MAN is a separate company, B&W is a separate company, and they have joined hands to be one corporation, one corporation company having two companies. Similarly, Sulzer and Wärtsilä are two different companies which were earlier running individual companies, but now because of commercial reasons, they have decided to join hands. So two organizations, each with a separate company. And Mitsubishi is the third Japanese company. MAN stands for Machine and Fabric, Augsburg, Nuremberg. It is a German company and it is located in a village called Augsburg, which is in a district or Paragana, which is called Nuremberg. You might have heard about Nuremberg being very famous during the Second World War, the Nuremberg trials. Do look up your Google. You'll have a lot of interesting stories. But MAN stands for Machine and Fabric, Augsburg, Nuremberg. It's a German company located in what is now Germany, what was earlier West Germany. They make some of the best engines and very reliable. B&W stands for Burmeister and Wain. I'm writing it down here so that you don't make a mistake with the spelling. And WAIN. And this company is coming from a small little company, a small little country, which is as big as possibly Chhattisgarh. And it is actually from Burmeister and Wain. And this particular company is from a country, Denmark. I think everybody's heard of Denmark. They are the manufacturers of B&W engines. They are also very good engines, very reliable. Sulzer. Sulzer is a company originating in late 1800, 1890, 1895, sometime then. And they were started by two brothers. They were called Sulzer brothers. And this is from a country which is landlocked, which means they don't have a sea surface anywhere. But they manufacture marine diesel engines, the best in the world. They are located in Switzerland. I think everybody has heard of Switzerland. So Sulzer comes from Switzerland, B&W comes from Denmark, MAN comes from Germany. Wärtsilä is also a very famous company and it is part of a conglomerate which is called Fincantieri. Obviously, the country is Finland. So you have Finland manufacturing Wärtsilä, Switzerland manufacturing Sulzer engines, Denmark manufacturing Burmeister and Wain, and MAN from Germany. These three organizations are the only three organizations which provide large bore two-stroke diesel engines. Today, if a company wants to start manufacturing large bore diesel engines, they are going to pay a very heavy price and their engines are going to cost much more than what these people can survive. They have their infrastructure in place. They have their arrangements in place. They don't need to set up anything. So if somebody wants to start manufacturing, he has to first set up. And the costs involved are so high that it is financially not feasible. So I suppose we are going to stay with these three companies who are going to manufacture a two-stroke engine for diesel ships. All right. There are other Gotaverken and some other companies, Harland and Wolff, but they have finished. They are no longer of any consequence. They were also competing with MAN, B&W, Sulzer and Wärtsilä during their heyday when they were operating alone. Now that they have formed a corporate, they have become much stronger. So the advantages of both are being put to use to get advantages in totality. So it has become very strong and very advantageous to them. I would like you as an assignment to prepare for an engine which Wärtsilä makes. And that engine is called W64. This engine, we have already started on our medium speed engine. It's the largest medium speed engine in the world. And it is 640 millimeters in diameter for the piston. And normally anything larger than this has to be a two-stroke. But this gives power equal to some of the two-stroke engines, and it is used for marine propulsion. So do read up on W64 Wärtsilä engines. This is from Wärtsilä, W-A-R-Tsilä. So I'm going to keep my information up to this level. I think I've given you enough information to actually digest, ingest, swallow, and absorb and be able to recall. One is I want the 5 temperatures: flash point, fire point, ignition point, pour point, and cloud point, well understood. Next class, ask me to clarify. I will clarify well, but you under no circumstances can afford to make a mistake in defining these 5 temperatures. Okay. Number 2, I would like you to make a sketch on your own and practice that diagram which I gave you, simple diagram, line diagram of the main engine 2-stroke. Because if ever you are asked a question, sketch and describe a 2-stroke engine, that is the diagram you will fit, not the colorful pictures that I have put up over here for making you understand. It is not possible for you to draw those colorful pictures, but it is possible for you to make those line diagrams. Third one, I want you to explore and find out about W64 Wärtsilä engine. It is the most powerful medium speed engine as of today. All right, that will be all for today. Now, if you have any questions, let me know, because I will keep it at this for today. There's enough information doled out to you. In the next class, we will do medium speed engines, V-type engines, their advantages, disadvantages, etc. Any questions? No questions. 35. So where is the one boy who has disappeared? One boy has disappeared. Are you there? Or you just put your laptop on and disappeared? Any question, put it on the chat, because sometimes it comes as a lot of loud but very disturbing sound. Any questions? Saurabh Kumar, I hope you have understood what happens to the air after passing through the air cooler.
Yes, sir.
Remember the names of the engines: MAN, BMW, Sulzer, Wärtsilä, Mitsubishi. If you're asked, who are the manufacturers of 2-stroke engines in today's marine world? So you should be able to rattle off 5 names. In fact, all the small part A questions in your exam will come like this. Name 5 2-stroke marine engine manufacturers. I will put a question like this. You should be able to rattle off. What stands for MAN? What stands for B and W? All right. It is not BMW. Remember. Okay, that is also a question. What stands for BMW? Everybody has seen BMW cars on the road and you admire them. Ah, that is a BMW. But what does BM stand for? Oh, sorry. Sorry. BMW. No, Saurav Gupta, it is not Burmester and Wain. That BMW Burmester and Wain is for marine diesel engines. BMW is something else. What is it? That car manufacturer.
It's Bavarian Motor Works.
Yes, Bavarian Motoren Werk. W-E-R-K. It is. I'll give you the spelling. B-A-V-A-R-N-O-T-O-R-E-N Okay, Bavarian motor and work. This is how, why it's not coming? Oh yeah, sorry. I was yes, yes, you're right. Saura Gupta, you're right. Bavarian motoren work. Motoren work. See the spelling of work. It's a little different. This is the real spelling. Anyway, we'll call it off for today. I hope I've tried to make it as interesting as possible so you don't fall asleep in front of your laptop. Sometimes speaking in front of the laptop, I start feeling sleepy. And you might have observed me trying to yawn. But that's the way we have to get along with in today's world. This corona has given us a lot of problems, but we have to overcome this problem. It is our will, it is our determination that we'll go through the subject, learn the subject, and be competitive enough. All right?
Excuse me, sir.
Yes, go ahead.
Sir, can you upload the today's
Lecture.
recorded lecture on the Google Classroom, sir?
Yes. Who is the monitor? Shubham.
Yes,
Shubham.
sir, I'm speaking.
Okay.
Yes, sir, I'm speaking,
Shubhankar,
sir.
I will send the link to you. You send it to all the class boys. Okay?
Okay, sir.
Okay,
Thank you,
right
sir.
on. Okay, bye bye. Take care and don't fall sick under any circumstances. Take care of your health more than anything else. That will be all. So I'm stopping the recording.